Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized, easy-to-digest chunks.
Today, we're looking at something you might have noticed yourself when playing with AI chatbots. They can write poetry, code, and summarize complex documents, but sometimes they make, really weird grammar mistakes.
Exactly, and not just random mistakes, but mistakes they seem to make over and over. It's like they get an idea stuck in their head and can't shake it. A new paper asks why. It's titled, How Large Language Models Get Stuck, Early Structure with Persistent Errors.
It's a great title. It sounds like the AI needs a good therapist. So what's the big idea here?
The researchers wanted to see not just what mistakes these large language models, or LLMs, make, but when they start making them. They had a hunch that many of these persistent errors aren't learned late in their training, but are actually baked in very, very early on.
So they're not getting confused after learning a lot. They're starting out on the wrong foot and just running with it?
That's the theory. To test this, they didn't use a massive, fully trained model like GPT-4. Instead, they trained a smaller model on a smaller dataset called Baby LM. The idea was to create a more developmentally plausible environment, a bit like watching a child learn a language from a limited amount of information.
Okay, so you have your baby AI. How do you give it a grammar test?
With a very clever tool called the BLIMP benchmark. Imagine a huge multiple-choice test for AIs with 67 different sections, each one testing a specific, tricky grammar rule in English.
And how does the AI answer the questions?
For each rule, the test provides a pair of sentences. One is grammatically correct and the other is incorrect. For example, which paper did Jason file before he read the report? Which sounds natural. The incorrect version might be something like, which paper did Jason file the report before he read? Which is just awkward.
Right, I can hear the difference. The second one is clunky.
Exactly. The AI's job is to pick the better sentence. It does this using a measure called perplexity. You can think of perplexity as a measure of surprise. A well-formed grammatical sentence should be less surprising to the model. It should have low perplexity. An ingrammatical, clunky sentence should be more surprising and have high perplexity.
So a correct answer is when the AI says the good sentence is less surprising than the bad one, and they tracked this throughout the BBAI's entire childhood or training process.
Precisely. They saved snapshots or checkpoints of the model as it was learning, and the results were fascinating. The model learned a lot of the grammar rules correctly, and it learned them very early in its training.
That's the good news. What's the bad news?
The bad news is that for nearly a third of the grammar rules, the model consistently got it wrong. It would actually assign a lower perplexity, a lower surprise score to the ingrammatical sentence. And crucially, this wasn't a mistake it made late in training. It made the wrong choice early on and then doubled down on it. It got stuck.
That is so interesting. It latches on to an incorrect pattern and just can't let go. So the big question is, why? What makes it get stuck on the wrong answer?
This is the core of the paper. The authors propose something they call the Big Gram hypothesis. It sounds technical, but the idea is actually simple.
Lay it on me.
A big gram is just a pair of words that appear next to each other, like thank you or of course. The hypothesis is that early in its training, the baby AI is very simple-minded. It's not thinking about complex sentence structures. It's just looking at which pairs of words are the most common. It takes a statistical shortcut.
Can you give me an example of how that would lead it astray?
The paper has a great one. The AI is given two sentences. The good one is, Patrick is irritating to talk to. The bad one is, Patrick is about to talk to. Now, in the context of the specific grammar rule being tested, the first one is correct.
But I can see the problem. The phrase is about is incredibly common in English, way more common than is irritating.
Exactly. The baby AI, just looking at word pairs, sees is about and thinks, aha, I've seen this pair a million times. This sentence must be a good one. It ignores the more complex, long-distance grammatical structure of the sentence and just goes with the most frequent local word pair.
And because that shortcut works so often with common phrases, the model reinforces that incorrect way of thinking and gets stuck, never learning the deeper, actual rule.
That's the Big Gram hypothesis in a nutshell. The model learns a shallow, statistical trick that unfortunately leads it to the wrong conclusion for these complex grammar cases, and it learns this so early and so strongly that it never recovers.
And the researchers were even able to pinpoint the exact moment this happens.
They were. Using a statistical method called change point detection, they could look at the model's performance over time and identify the specific training iteration where its preference for the good or bad sentence locked in. It's like finding the exact moment a bad habit is formed.
So it's a fascinating look into the mind of an AI, showing how it learns and where it stumbles. It's not just a black box, it's a system that takes shortcuts, forms habits, and gets stuck, just like us.
It really is. The paper gives us a glimpse into the AI's developmental psychology, revealing that its biggest, most persistent mistakes are often born in its earliest moments. And that's all we have for today on Daily Papers.